Welcome all to the lecture series of vector calculus. So this is actually the last part of module 3 of your first year engineering mathematics syllabus. So first we will discuss what do we study in the vector calculus and what are the topics that I am going to discuss. Then I will start with my own topic. So myself Santanu Das, Assistant Professor, Department of Basic Science and Humanities, IIM Kolkata. So before starting with the vector analysis, we need to deal with the scalar or vector function. So already we have studied what do you mean by the scalar and vector. So now we'll you know also the functions. So now we'll deal with the scalar and vector functions. So first, what do you mean by the scalar function? So scalar function is nothing but a function that assigns some particular scalar value, that means real value, for to some real variable. So what is the scalar function? Scalar function actually tells us that it will assign some real value to the real number to a set of variable. So what does it mean actually? So in general, we can define the scalar function as u functions of x1, x2, xn. That means x1, x2, x3 up to xn, they are n number of real variable or real numbers. So that means they are scalar numbers. So corresponding to each of these values, by varying those values, we can get actually the values of u. So u here is nothing but a scalar number. So that's why it is called as the scalar function. That means some variables are there. By varying that variable, so they are all real variables. So we are getting actually one scalar value. So this kind of function is called as the scalar function. Now we'll discuss about the vector function. So you know the vector value. So whenever we are assigning some real value or we are varying the real variables, and corresponding to the real variables, we are getting actually the output as a vector value. So that is actually called as the vector function. So here a vector function f can be defined in the form of say x1, x2, x3 are varying. So if we are considering the vector in the three-dimensional plane. So in three dimension, you know that each of the vectors must have three components. So the component corresponding component parallel to the x-axis is f1, component parallel to y-axis is f2, and component parallel to z-axis is f3. So actually, what are the variables? So x1, x2, x3, xn, they are all variables I am considering as the in the general case. So x1, x2, xn are all real variables. So the x component will be also dependent on those variables. The y component, that is f2, will also be dependent on those variables, and f3 will also be dependent on those variables. So together, by combining the components, we can actually determine the function that is a vector valued function. That means we are varying the values. By varying the real variables or real values, we are actually getting a vector function or vector value that is denoted by f. So that is called as the vector function. Then we'll discuss about the function which is defining a curve in the space. So what does it mean actually? So let us consider a three-dimensional geometrical figure. So this is a three-dimensional geometrical figure. So let us consider, you know, the Poisson vector of any point in a plane. So what is the Poisson vector? So if P is a point, so since we are considering this point in the three-dimensional plane, so actually there will be three components. So x, y, z component. So actually the R is the Poisson vector of that point in a three-dimensional plane. What do we mean by the Poisson vector? Poisson vector is nothing but the vector that is directed towards that point and that initiates from origin. So actually, if we consider any arbitrary points, say this is your P, that is P1, this is Q, this is Q2. So all these are points, and we can identify those points, they are all the vector valued points in a plane by considering their positional vector. So if we join those points, we will get an equation of a curve. So what is the general equation of that curve? So general equation of that curve is defined by RT equals to XT I plus YT J plus ZT K, where XT, YT, ZT are actually the x, y and z component, x, y and zth component. So you know the parametric representation. If all these variables x, y, z are dependent on another variable, so that is t. So then x can be written in the form of xt, y can be written in the form of yt, z can be written in the form zt. Now if we vary the value of t, then we can identify x, y, z. So by varying the value of t, we can identify different x, y, z. So actually RT is the general notation of the Poissonal vector of any arbitrary point. So if we consider the locus of all such points, so this will give us the equation of a curve. And generally the equation of a curve in three dimension is defined by that in the vector form. Then function defining a surface in space.
So what does it mean actually? So you know that whenever we are considering a car, so that is actually how many variables are there? That is a function of one variable. That means x is dependent on t, y is dependent on t, and z is dependent on t. Now, if we consider a function of two variables, that means the x, y, z are not dependent on only one variable t. Rather, they are dependent on two variables u and v. So x is dependent on u and v, y is dependent on u and v, and z is dependent on u and v. So if it is dependent on more than one variable, then we know that the geometrical figure that we'll get, we have already studied in function of two variable, which last part we are actually discussing in the form of the vector analysis. So actually you know that if I consider a function of two variable and geometrically this represents the equation of a surface. So actually the general form or notation of a surface in the form of a vector is denoted as RUV, it's XUVI plus YUVJ plus ZUVK. So here x is the x component, y is the y component, z is the component along z axis. So here if we consider v as the parameter and u as a variable, in the system describes a space curve. That means if I fix here u and vary the value of v, then only one variable will be there, so this will represent a curve. So if I vary the value of v by fixing u, then we will get the v curve. Then if I fix the value of u and vary the value of so if I fix the value of v and vary the value of u, I will get different u curve. So combining this u and v curve, we will get if these two curves intersect each other, whenever we are varying both these curves, and it gives us the equation of a surface. So you know about the latitude and longitude. What is the latitude and longitude? So latitude is this kind of curves and longitude is this kind of curves. So whenever they are intersecting, so that the point of intersections is given us the location of any arbitrary point in the R. So that is actually UV plane. So in UV plane, this is the UH curve. So whenever we are varying, so this is actually UH direction, this is actually the VH direction. So whenever we are varying the value of U by fixing V, we are varying the value of U. So varying the value of U means this is a V curve, this is a V curve, this is a V curve, this is a V curve. And if we are varying the value of U, V is fixed. Similarly, whenever we are varying the value of V by fixing U, then we are getting different U curves. So the point of intersection is actually identifying the location of a particular point. Now, if x, y, z are three variables which are dependent on this u and v. So if we represent this in three dimension, so this point actually is this point. So that is actually the uv point, by depending which we are actually identifying the point, that is x, y, z. That is a point in three dimension. So that is called as the parametric mesh, because we can represent x as xuv, y as yuv, z as zuv. So UV is actually nothing but the intersection of two curves, U curves and V curve. Now if x, y, z are the position of any point that is dependent on that two vector, two values u and v, or two variables u and v, so thus we can consider or construct any point in three dimensional. So that is actually the U curve, that is actually the V curve. So whenever they are intersecting, so actually we are locating a point. So since this point is in the three dimension, so there will be three components, so x, y, z components. Now this x, y, z is dependent on this two type of curves, that is the latitude and longitude. Okay, so in that way we could define actually a function in one variable that is representing a curve. Whenever we are considering a vector valued function in two variables, that is representing a surface in three dimensional plane. So that is all about the scalar function, vector function, and how we can generate a curve by considering a vector valued function by varying only one variable, and how we can generate a surface in the three dimensional plane by varying two variables in a vector valued function. So thus we have considered all these things in that lecture. So the next lecture I will discuss about the scalar field, the vector field, the point vector, the scalar point function, the vector point function, etc. So till then stay tuned. Thank you all for watching this lecture.